Oke, halo. Jadi buat sorry. So for this question, I'll be using English because I can explain better in English, in my opinion. But if you do feel that my explanation in English is not satisfactory, you can feel free to chat me and I'll make a new one in Indonesian. So yeah. Okay. So first, what we need to know is this is being done in an acidic condition. And what happens in acidic conditions is uh, the hydrogen will be attacked by a nucleophile. In this case, the nucleophile is the oxygen because oxygens are um, they're more electronegative and uh, they are nucleophilic, so they will attack the hydrogen. And what happens after they attack the hydrogen is uh, this will create an ion that's like this. Wait, sorry, my type is lagging. It will create an ion like this, where it's positive. And what happens here is um, this is, as I said, it's a good leaving group, which means there will be a lot of force being pulled onto it. But since this is an epoxide ring, what happens is this will not actually leave, but this will cause the force that's being pulled up here will cause disturbance, and the epoxide ring will eventually break. Now, what we have to determine is which carbon will let go of the oxygen. And to answer that is we have to know about carbocations. So carbocations are carbons that are cations, so they are positive. Uh, so carbon cations are more stable the more substituted they are. So if they are tertiary, they will be more stable. And in here, obviously, we want a more stable product. So we aim to uh, find the most stable carbocation. And to do that, we must cut off this one. Why, you may ask, is because, and then C, yeah. So this will break off and this will still stay. And as you can see, this will create a tertiary carbocation, and this tertiary carbocation is more stable than if the carbocation was on this carbon, because this carbon is less substituted. Remember, substituted just means how many other things are attached to the carbons, specifically how many other carbons are attached to that carbon. And you may ask, oh, the charge was on here. How can it just jump? Yes, so charges can jump. And what this charge will do is it will actually go here, so it can create a more stable form, which is a tertiary carbocation. So after a tertiary carbocation is made, um, the next thing that happens is uh, the acid will uh, coordinate this, and this will be attached to a hydrogen. My tab is lagging. I am so sorry. Okay, I have to click, and this will be attached like this. 1, 2, 3, OH, 1, 2, 3, 4. Oh, sorry, I forgot about the this the methyl, the methanol. Okay, so this will be a carbocation, right? What happens next is this will be attacked by the methanol. So the methanol will attack here and attach itself to here, which will create this product. So HO C C C C and O CH3 like that. So the product is like this. Now, um, I'm not done with the explanation. To answer this question, we actually have to compare to if it's in a basic condition. So, uh, in summary, if it's in an acidic condition, it will first create a carbocation, and after and only after that carbocation is made, the methanol will attack the carbocation, creating this compound. Now, what happens if this is in a basic condition? If it were if it were in a basic condition, uh, I'll erase this because it's video. If it were in a basic condition, wait, okay. If this was basic, there is in a basic condition, there is no proton that can protonate this oxygen, right? So what happens is there will be a more direct attack. What will happen is methanol will actually become a strong nucleophile like this, and it will directly attack. So this uh, methoxide, if I'm not wrong, methoxide ion will force the ring to open. However, it will force the ring to open with an SN2 mechanism. So you might be thinking, oh, okay, the basic thing is this nucleophile will attack a carbon that's attached to the epoxide on either here or here. But which one will it? But which carbon will it attack? So because of steric effect, the the nucleophile will attack the least substituted carbon, which is here. So this will break off, and it will be like this. O, and it will create this compound. So in summary, what happens if it's in a basic condition is there is no carbocation to be made, but since it's in a basic condition, this basic condition essentially um, changes the sifat. I forgot what sifat is. It changes the sifat of methanol, where methanol also becomes very basic, and or you can think of it like this: it reacts with methanol plus OH, H2O, and CH3O minus. Now, this is a strong nucleophile. Strong nucleophiles means they can react by directly attacking, and this will directly attack at one of these carbons because uh, these carbons are electrophilic towards the nucleophilic oxygen. Now, why will it attack this and not this? Is, oh my god, I don't know why this is like bugging out. I'm sorry. Because think of it like this: since this directly attacks, If we compare like this carbon, the carbon has four sides that it's connected to. That's not hydrogen. And these four sides are big functional groups. They're all methyl. And it's like trying, uh, okay, this might sound really bad, but it's like trying to uh, talk to a person with a really huge body and a really big butt. So like this, right? Like from any direction you can't go. So that's the steric effect. I'm not fat shaming, but this is like the best way to I can describe it. Like you can't go back because he also has a big back. Okay. So the nucleophile, which is the methoxide ion, will prefer to attack this because this only attached to is not only, but it has two hydrogens attached to it, which are less big than this. This is very bulky. So in summary, uh, for epoxide rings, acids will cause protonation of the oxygen, and this will create a carbocation where carbocations will prefer more more substituted uh, carbons, and because carbocations are positive, they will be attacked by the methanol. They will be attacked by methanol. Meanwhile, in basic conditions, this will create uh, direct attack from methoxide ions, which will attack the less I'm sorry, my handwriting is so bad. Substituted carbon due to steric effect. So, in short, for number three, the reason why the main product is this is because this product is made by uh, attacking the more substituted carbon, which is done in acidic conditions. Hope that helps.